Hi, I'm Kai. I'm going to do the question 2 of homework 2 for probability and stochastic processes. The, the, the problem 2, and given the probability of x1 equals 0 is 0.2, and the probability of x1 equals 1 is 0.8, and the conditional probability. And now we need to compute some probability. And the first question 8, we need to find the probability of x2 equals 1. And there are two possibilities, and the first one is x2 equals 1 when x1 equals 0, and the second one is the probability of x2 equals 1 when x1 equals 1, and we can add these two conditional probability together, and the final result will be 0.64. And the second question, the problem B, and we need to find the probability of x3 equals 1. And we can multiply the probability of x1 equals 0 and x1 equals 1 by the conditional probability matrix, and we need to find the probability of x3, so we need to use the square of the matrix. So the final result would be 0.408 and 0.592. So the probability of x3 equals 1 is 0.592. The problem C, we need to find the conditional probability x1 equals 0 when x3 equals 1. We can use Bayes' theorem and rewrite this as the probability of x1 equals 0 and x3 equals 1 over the probability of x3 equals 1. And then we rewrite this one as the probability of x3 equals 1 when x1 equals 0 times the probability of x1 equals 0 over the probability of x3 equals 1. And this one we already know it is 0.2, and this one we can get this one from the problem B, and it is equal to 0.592. For this one, we notice that if we take the square of the conditional probability matrix, and we will get the conditional probability of x3. So we can find this probability here, and it equals to 0.52. So we get all the values we compute, and the final result is 0.176. The fourth problem, the problem D, we need to find the probability of xn equals 0 when n approaches infinity. Again, we can use the probability of x equals 0 and x equals 1 times this conditional probability matrix. But this time we need to compute the n power of the matrix. So let's say the matrix is 8, and we can find the eigenvalue and eigenvectors for this matrix A, and then we can find a invertible matrix P, and let P inverse times A times P equals B, and B is a diagonal matrix. And then we can compute the diagonal matrix B, the power, the n power of B, and then the power of the n power of 8 is P times B to the power of n times P inverse, and the result will be 3/7 and 4/7. So the probability of xn equals 0 when n approaches infinity will be 3/7.